Okay guys, Bryar wanted an explanation of how you turn alternating current, or AC, the stuff that comes out of your wall, into direct current, or DC, the stuff that comes out of the battery in your car that would also charge your phone. Important thing to know is what is the difference between AC and DC. AC is consists of what's called a sine wave, or a sinusoidal wave. It goes from 0 volts to 120 volts positive, to 0 volts to negative 120 volts, then to 0 volts. That is happening at a rate of about 60 hertz. So whereas DC, AC goes up and down, DC can only ever be positive. It's always it never goes to negative. So you got 0 volts to 120 volts, and it just stays on and it turns off. It's kind of a digital affair. It doesn't have to be digital, but that's what we're trying to get to. I'm going to explain a little bit more about how a sine wave works. So in this example, we have our sine wave here. We're going to think about this as the Kentucky Colonel Sanders needs help making a big order of chicken. And we have the, right now it's middle of summer, so Japanese Colonel Sanders is in his off season. It's not Christmas right now. So what we're going to do is we're going to ask the Japanese Colonel to help us do work to make our chicken. So what we need to do that, for that recipe, we need a couple of components. We need a diode, a resistor, and a capacitor. So our diode, it works like a check valve. It only lets electricity go in that direction, the direction of the arrow. A resistor is our work that we're doing. This is the chicken that needs to be made. Our capacitor is a little bit of a treat later. This stores energy and discharges energy fast, really, really fast. This is going to be our cans of RedBull. That'll make sense in a second here. So this is our circuit that we need. We have 4 diodes and a resistor. We have our check valves, and we have our work that we're doing. And then we have our AC power source here, positive voltage and negative voltage. When this is positive, we're taking this part of the sine wave. When this is negative, we're taking this part of the sine wave. So first we have our positive voltage. We have positive voltage comes in here. It can't go through here because that arrow is the wrong way. It has to go through this arrow. It can't go through that arrow because that arrow is the wrong way. So that goes to our resistor. It does a little bit of work. It comes back. Comes back. It can then go into here, go back into the circuit, and it goes back here into negative. When we have the negative side of our circuit, it does the same thing, but it ends up coming back to the positive. So our positive cycle looks like this, and our negative cycle gets flipped upside down. It looks like that. So now we have a bunch of bumps here, right? So this is basically because our 2 kernels are on 2 different sleep cycles. This guy's from Japan. He's on the other side of the world. This guy's from Kentucky. So during the positive cycle, he's awake, and during the negative cycle, he's awake and he's asleep. So now we've got it. So this guy's awake, and then he goes to bed. Now this guy's awake, and he goes to bed. Wake, bed, wake, bed. So what we need to do is we need to give these guys a little bit of kick in the pants, give them some energy, so we can smooth that out and use it as a smooth DC. Because otherwise, it's going to be no power, all the power, no power, all the power, no power, all the power. So if you're like in an electric car that did just that, you'd be like pop, 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 pop. Instead of being like So what we're going to do is we're going to take our 12 Red Bulls here, we're going to tack that on, and that's just going to give us a little bit more juice, a little bit more energy. So anytime that we're at a 0 state, this guy's, as we're climbing, this guy gets charged up, and as we're at the peak, this is charged. As we start to get down, this guy will discharge, put a little bit more electricity into the circuit, and it'll even things out, and that kind of looks like this. You can see there's still a little bit of a bump, and I left that bump to explain that we're not actually just going straight DC. We're not going with a straight signal. It still has some ripple in there, and with a better capacitor as a filter, that ripple gets evened out. So and that capacitor, like I said, is our 12 cans of RedBull. And the reason I use RedBull is because capacitors look like that. They look like a can. Electrolytic capacitors do anyways. So that smooths it out. And that is what gives you DC power for like your phone or for like anything that uses a takes in 120 and turns it into DC power. That's what's going on there. So in summary, we got Kentucky kernel, Japanese kernel. They both want to work together, so we flip Japanese kernel and we bring them over to Kentucky, which is what we're doing here. Now both Japanese kernel and Kentucky kernel are in the same place, but Kentucky kernel's working during the day, Japanese kernel's working at night. They're not working together. We need to get them to work together, so we're going to give them both RedBull, so they're always awake and they never go to fucking bed and they make me my goddamn chicken. That's it.